he's not making it. Clay is going to be asleep in seconds. And then we're back to 37 degrees. Yes. In quadrant 1, the reference angle is the angle. We agree? Yes. So this is 37 degrees. In quadrant 2, we do 180 minus the reference angle, and we get 143. Yeah. Quadrant 3, we add 37 degrees to 180, and we get, that was inflecting, and we get 217. Very good. And 360, quadrant 4, minus 30, it actually hurts to talk like this, my cheeks hurt. Minus 37 is 323. Good job, guys. I'm going way too slow. I can't do it. Okay, quadrant 1. There we go. I feel better. I'm in my own zone again. This is good. Okay, 0 degrees or 0 theta. Is this a 0? Because people tell me it's a 0 all the time. No, it's a theta. So in quadrant 2, it's going to be 180 degrees minus theta degrees. In quadrant 3, it's going to be 180 degrees plus theta degrees. And in quadrant 4, it's going to be 360 degrees minus theta degrees. If that was just theta, we would assume it to be radians, correct? And then we'd have to go pi minus theta, pi plus theta, 2 pi minus theta, right? We'd have to use the actual theta. Okay, so if it's 177, how far away is that from 180? Oh my gosh, you are late. Wipe your desk. Sit down. Tally ho. Okay, 180 is how far? 177 is 3 degrees. Quadrant 1 is the same as my reference angle. Quadrant 3 is 180 plus 3 degrees, which is 183. Quadrant 4 is 360 minus 3 degrees, which is not a 2. Try that again, Lepp. 357. 225 is how far away from 180? 45. You have the quiz. You can find it. I gave it to you. 45 degrees away from 180. So it's quadrant 1 is 45. Quadrant 2 is 180 minus 45, which is 135. Quadrant 4 is 360 minus 45, which is 315. 299 is 61 away from 360, which is a 61 degree at the beginning. 180 minus 61 is 119. And then 180 plus 61 is 240. The angle negative 483 in standard position terminates in what quadrant? So what we can do is we could draw it going clockwise, correct? Or we could find its coterminal. So we go negative 1. What? Negative 483 plus 360 gets me negative 123 degrees plus 360 gets me also helpful, 137. What quadrant is that in? I think it's 137. Is it 137? It's 237. Oh. 1 and a 3 makes 2. Some good subtraction there, Lepp. Grab a minute. Get in the game. Okay. 237. So we're in quadrant 3. 180, 270. Three, which one of these 4 rotation angles is not coterminal with the other? Which one doesn't work? A, B, C, or D? A. Because if we go 158 minus 360, it does not equal negative 2AT, right? The statements that are true. In quadrant 1, the rotation angle is equal to the reference angle. That is true. In quadrant 2, the rotation angle is equal to 90 plus the reference. No, that's going from the y, so that's not good. In quadrant 3, the rotation angle is equal to 180 plus the reference. That's true. In quadrant 4, the rotation angle is equal to 270. Nope, we never use the y. So it would be 360 minus the reference angle. So it's 2 and 3. And 1 and 3. It's 1 and 3, not 2 and 3. Couldn't have picked 2 and 3 anyway. Wasn't an option. That would have stopped me from being stupid. Okay. An angle theta is coterminal with negative 163 divided by 360. No way. So we go 163 degrees plus 360, and we get what? 197? And 197 falls between 0 and 360, so we're good. Which is illegal in all 52 states and a whole bunch of provinces. Because I didn't put no degrees. So technically, you would have actually had to find it between 0 and 360 radians, which would have been a lot of answers. That's all I'm saying. Been cray-cray. And because the first rotation is in between, if I turn a 2 pi into a decimal, it's like 6.something28. So 0 to 6.28, we get you all the angles in the one reference, and then I have to go 360. Should be a lot. All right, pendulum swings 12 centimeters long in an arc. Pendulum 12 centimeters long, which I've given you this one before, so that's my radius. In an arc of 6 centimeters. They have to be in the same units, right? To the nearest degree, the angle through which, I thought I spelled it wrong, but I didn't. I did spell it right. Through which the pendulum swings is. So theta equals A over R. So we're going to get theta equals A over R, which is 0.5 rads. Now radians to degrees, RD-POB, right? Radians to degrees, pi on bottom. Because remember, this formula is always in radians, never in degrees. So pi on bottom, so we go 180 times divided by pi. So it's going to be 90 divided by pi, which is, how many? Is it 29? I don't know. Because pi is 3.1 something something, so yeah.
How do you know when to use radians or degrees?
So you have to, if you use this formula, you have to have it in radians. If you get an answer out of it, it's going to be in radians. So you have to convert.
Oh, okay.
Yeah. So the only way you can use this formula, so they'll either give you this, like I did, so I gave you arc and radius and then ask for degrees, so you have to convert. Or I'll give you the arc and the radius, or the arc and the, my goodness, blanking, D, diameter. Wow, that was hard. So they'll either give you the diameter and you have to cut it into 2,
Yeah,
and give you a degree, and you'll have to convert it to radians to put it into the formula. So the key thing is that people forget that that has to be radians no matter what. So you either get an answer in radians and have to convert, or they give you a degree, you have to convert to radians and use it. It's always a step in there. They're never that nice to give you the radians and ask for it in radians, right? Because then it would just be like a grade 10, science 10 question, if not. All right, can you flip to your notes? So yesterday we discussed when I gave you 2 coordinates, or a coordinate, and you drew the coordinate, you found the radius, and then you could give me all the trig ratios. We agree? Or you could give me the angle, right? Using one of the trig ratios. We agree? And I always gave you a point, and it was always an xy. Yes? Okay. Today, and you have to be able to spot these ones, because they pop up all the time. It says, given the trig ratio and the quadrant of a particular rotational angle, and that's the key thing. You'll be given a trig ratio, and you're given the quadrant of a particular rotational angle. You need to be given 2 things. I don't know why that just raised. If you're given those 2 things, you're going to do these same steps every single time. It's very, 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 very similar to the coordinate, except now they could give me a y and an r, or an x and an r, or, or an x and a y too still. But it's not just in a plain old coordinate, it's in an actual trig ratio. Okay? So we're still going to draw it like we did before. So we know to use this one. It gives you a trig ratio and a particular angle. Find all the other trig ratios. So it's the exact same as yesterday, and the corresponding angle. Exact same as yesterday, but instead of just giving you a coordinate, I might give you an x and an r, or a y and an r, right? Or an x and a y. So tan, what's the acronym for tan? Tan, we don't want it to have a D deficiency. Tan, your X box, right? You don't want it to have vitamin D deficiency. Okay, now the key thing is tan in quadrant 1, both of these are going to be positive, right? So if I go to draw it, I'm actually given x and y again. X is 5, y is 4. I draw my terminal arm, and I draw my bow tie triangle. And I label, this is 5, this is 4. So is this any different than yesterday? Could I have just said the point 5, 4? Could I have just given you the coordinate 5, 4 just instead of doing it this way? Yeah, it would be the exact same as yesterday. Now I still need to find the third side. It's just not always going to be r this time. This time it actually is, but not all the rest are going to be r. So we're going to go r squared equals 4 squared plus 5 squared. R squared equals 16 plus 25. R squared equals 41. Square root. We need plus or minus. Whenever you take the square root, you take the positive or negative of it. So r equals what? What is the radius always? Positive. So it's going to be root 41. For time constraints, we're not going to do all the remaining ratios. We're just going to do 2, and I'm going to tell you which ones. Okay? So I want you to do cosecant theta, and I want you to do cos theta. You give me those. Cosecant is best used with sine, and sine's acronym is sign your resume, right? So this is going to be resume your. So cosecant theta equals root 41 over 4. Cos is cooked extra rice. So it's going to be 5 over root 41. But then I need to rationalize. So I multiply by root 41. So I get 5 root 41 over 41. Okay? How did I get my reference angle? How did I get the angle of that actual thing? What did we do yesterday? We took one of the trig ratios and solved for the angle, correct? The trig ratio I'm going to pick is a primary. If I'm stuck, I'm going to pick a primary because the primary trig ratio is right off of your calculator, right? You have cos and you have sine and you have tan buttons. So I'm going to do the cos one. So I'm going to go cos theta equals 5 over root 41. Then I'm going to go cos neg 1. Cos neg 1. Theta equals cos neg 1. And we can do it in degrees for now. Make sure your calculator's in degrees. So if you go second cos, 5 divided by root 41, what do you get? It's the nearest 10. So our reference angle, if we want a reference angle, we always take the positive of whatever the question is. So we got 38.7, and it happens to be that it's in quadrant 1, so it actually is. Theta is 38.7. When we do this, though, when we do this with just the trig ratio, we're getting the reference angle. Okay? Just happens that the first quadrant angle is the same as the reference angle. Right? So they're not always the same. Yeah? Yes. Okay, this one. Sine. What's the trig ratio acronym for sine? Sine your... What do we want to sign? You could sign a receipt. I said resume, but I like receipt. You could sign your... Your what? Your report. You could sign so many things, right? Just make sure that that signing thing starts with a knot. Okay. So I'm going to say sign your resume. You could say sign your report, sign your receipt, sign your reclamation document. I don't know. Sign your ransom. You do so many things. We could sign our ransom in this class, sure. So we have y and r this time, but we don't have x, correct? Now, the problem with having y and r is I have a positive y. So if I have a positive y could terminate here or could terminate here, couldn't it? Right? So I could technically get two spots. We agree? But they'll give us a second piece of information that tells us where it actually terminates. So you have to recognize these questions because you're given a trig ratio, and then you're given a second piece of information which gets you where the terminal arm is. Okay? And then you draw. So we draw, and then we can trig ratio. So it's between 90 and 180, so it's here. Y is 3. We don't know what x is, so it doesn't really matter. We're just going to sketch a triangle here. Our y is 3. Our r is root 10. We need to find our x. So when we're missing r, we do r squared equals x squared plus y squared, correct? But when we're missing x or y, we're going to do r squared minus the other one. Remember how you rearrange your Pythagorean theorem? So x squared equals r squared minus y squared. So x squared equals root 10 squared, which is lovely because it just gets rid of the squared symbol, and 3 squared. So x squared equals 10 minus 9. X squared equals 1 square root. This is the catch though. When we take the square root, we need the plus or minus because we can actually have plus or minus 1 in this case, correct? We can't have it for radius. Radius for sure is positive. X could be either or. That's why you need to draw it. Because once you draw it, you're going to know it has to be what in this case? Negative. Because the x over here would have to be negative 1, right? When you're in quadrant 2, your y is positive, your x is negative. Now I want you to do for me, the sign, so I want cos theta and cotan. I want the reference theta, and I want what this actual angle is from here to here. I want that theta. We have. So cos is cooked extra rice. That's negative 1 over root 10. Multiply by root 10. And I get negative root 10 over 10. Or negative 1 root 10 over 10, same thing. Tan is tan your x box. So cotan is x box your. So it's negative 1 over 3. To do my reference theta, I'm going to use the cos one because it's just nice. Could I have used the sine one? Sure. Could I use tan? Yeah, doesn't matter. I'm going to use cos. So I'm going to go theta, reference theta. Remember reference angle is that little bow tie angle? So my reference theta is cos neg 1 of root 10 divided by 10. Did you see that I didn't put the negative sign in there? When you want to find your reference angle, if you put the negative sign in, it's going to give you a negative angle. If it's tan, it'll give you like a negative angle. You'll have to find the reference angle to it. Whenever you want to find a reference angle, you just use the trig ratio with positives. Because what trig ratio is positive in the first quadrant? All of them. All of them are positive in the first quadrant, right? And your reference angle is equal to your first quadrant angle, isn't it? So if we find the first quadrant angle every single time, we're actually technically finding the reference angle. It doesn't mean it might not be actually one of the answers, but it will always give us a reference angle. So when we want to find a reference angle, we'll do cos neg 1, sin neg 1, tan neg 1 of the positive, even if the answer is negative, because it'll give us our positive reference angle. So when you type that in, what do you get to the nearest 10? 71.6. So that's my reference angle. That's not actually this answer though, right? My reference angle is the angle from the x-axis to the terminal arm, correct? So that will help me get my actual theta. So that's this. This right here is 71.6. So how do I actually get the red angle? 180 minus the reference angle, right? 71.6. And what do we get? 10. 8.4. I believe. Okay? So we could be given the trig ratio, told what quadrant it's in. Given the trig ratio, indirectly told what quadrant it's in. Because between 90 and 180, that's quadrant 2, right? It's another fancy way. This is the most common way they do it. 3 and 4. So I'm going to do number 3, and then you're going to do number 4. But number 3 is sign. Now this is the catch. It's sign your receipt, your resume, your, what was yours again? Your ransom. There's so many things. So we know this is Y and this is R, correct? Sometimes it's written like this, guys. This would be the trickiest way to write it. And this is Y and this is R. And people will go and take that negative and say R is -3 and Y is 2. Is that true? Can R be negative? No. Can I move the negative around all I want like I told you yesterday? Yep. So this is the hardest way they could give the question because people will try and make R be -3 when R can't be -3. So the minus sign has to go to the 2, and then I just turn that into a plus. Because it has to go to the Y, right? Because my R can't be negative. So I go to draw it. Now this is where it gets tricky. So my Y needs to be negative. So my Y is negative here or here. We agree? Normally they tell us exactly what quadrant it needs to be in, right? Well, this indirectly tells us what quadrant. So we know it's in this one or this one because my sign is negative, or my Y is negative. And here it tells me my tan is greater than 0. When they say greater than 0, what are they indirectly saying? Tan is positive. Which of those two is tan positive in? Quadrant 3 or quadrant 4?
4. 3.
3. Because we have to use what rule? Half. Which one is tan positive in? This one, right? Cos is positive here, so it's not this one. So I'm going to draw it here. If it said tan was less than 0, I would have drawn it here, right? So my x, I don't know. My y is -2. My r is 3. I need to find my x. So I do r squared equals 3 squared minus -2 squared. R squared equals 9 minus 4. R squared equals 5. R equals plus or minus root 5. R? R? Why am I writing R? No one stops me.
That's what I was wondering.
Ah, it's an X. Let me just keep writing R's. Don't comment. It's fine. So X equals plus or minus root 5. If it had been in this quadrant, X would be positive root 5, correct? If it's in this quadrant, X is negative root 5. So we have to draw it in the right one. Because do you think I'll have the opposite multiple choice answer there if you screw up? Yeah, I will. Sadly, I will. So this is going to be negative root 5. So I want one more x's on the bottom. So I want tan theta. And I want cosecant. Nope. I want secant. So I want tan theta, I want secant theta, I want reference theta, and I want to know what the angle is of that terminal arm. Let's try that out. So tan, your x box, it's going to be -2 over negative root 5. It's going to end up being positive, which it should be, right? Since tan's in this quadrant and tan is positive in this quadrant. Multiply by root 5. And we get 2 root 5 over 5. Secant is the opposite of cos. Cos is cooked extra rice, so this is rice extra. So 3 over negative root 5. Rationalize. So you get -3 root 5 over 5. Or you could have said 3 root 5 over negative 5, totally fine. The reference theta, I'm going to do tan -1 of 2 root 5 divided by 5. And what do you get? Did anyone do it? Euler? Did anyone get the reference angle? Talia, do you have it?
I got 41.8 degrees.
41.8?
Yeah.
The jury agrees with you. The jury of your peers. You guys think judge you or something because no one answered the question. 41.8 degrees. Perfect. And then that's this, right? So I just do 180 plus 41.8 and I get 221.8 degrees as my actual theta. Cook extra rice. So this would have to be the negative, even if it had negative on the 13, right? I'd put it to the 5. Tan is negative, so my x is negative. Well, my x is only negative here and here. And I need to pick the one where tan is negative. So is that quadrant 2 or 3? 2, right? Because that's where tan is negative. So it's going to be here. This one's out. So it's negative 5 and 13. Then I do y squared equals 13 squared minus negative 5 squared. Y squared equals 169 minus 25. Y squared equals 144. Square root plus or minus y equals plus or minus 12. In this case, because it's in quadrant 2, it's positive 12, right? Cotan, tan your x box, so cotan is x box your. Sign your resume, receipt, ransom, wherever we want to sign. Something with an R. Sign your rabbit. Sign your really awesome new car. Okay. Sign your resume, receipt, whatever. So then the reference angle is going to be sine neg 1 of 12 over 13. What if it said one of these had been negative? I would still go 12 over 13, right? To do the reference angle, I still always do the positive. And what do we get? Hallie? Do the peers agree? They agree. All right. Now we need to get this one here. Boom, boom. And our reference angle is that, right? So theta equals 180 minus 67.4, which gets us 1. Voila. Okay? I'm going to give you a few minutes to work on this for homework, and then we're going to start the new thing, but I want you to practice these with it. So your homework is same page, one in Rome, keep 4.3ing it. These ones you just have to get the 5 other trig ratios. Right? There's 4 of them. I will give you approximately 5 or so minutes. Page 202, number 12. I don't like that one. I might. Why is that one so stupid? Halt. That's not what I want. Why? You're fine. You can try it out. Yeah. It's the exact same thing, but it'll be like between negative 180 and 180. So you'll have to look at negative 180, 180, which arm actually fits, by if it's a positive y or a negative y, etc. So it's a little bit different. Often they're like this. The textbook doesn't have those, so that's nice of it. A, B, C. So if we do tan, if it asks for the exact value and it gives you tan, cosine of whatever, this means we're going to use our unit circle. We did this yesterday. I think it was question 4. We're going to revamp over it again. So if I give you cos of anything or sine of anything, you pull it right off your unit circle, correct? If I give you secant, it's cos flipped. If I give you cosecant, it's sine flipped. And if I give you cos and tan, or tan and cotan, you have to use your formulas off the unit circle, or off the formula sheet. So at the very top of your formula sheet, it tells you tan theta is sine theta over cos theta, and your unit circle has sines and coses, right? Or if it asks for cotan theta, we're going to use cos theta over sine theta. So you're going to need your unit circle out, if you don't have it out already. So if we want tan of pi over 2, tan of pi over 2 I can't pull directly off my unit circle, but I can pull its formula. So remember, tan of pi over 2 is the same as sine of pi over 2 over cos of pi over 2. At pi over 2, we have 0 and 1. We agree? So the 0 is cos, and the 1 is sine, right? So we're going to get 1 over 0. Are we allowed to divide by 0? Absolutely. In the non-mathematical world, they would say yes. In our mathematical world, they say math ticket, $1,000. Worse than not stopping at a red light. That's what they would say in math world, but not in real world. Okay, so we would say 1 over 0, which they say is undefined. If it was 0 over 1, the answer would just be 0, right? That would be okay. Cosecant 7 pi over 6. Cosecant goes with sine. Secant goes with cos. Remember, C's don't go with C's, S don't go with S. So this starts with a C, it goes with sine. So I go to 7 pi over 6 on my unit circle. I look for my sine, Calgary Stampede, so my sine is the y, and I do what to it? Flip it. So what is it at 7 pi over 6? Negative a half. So we know that sine at 7 pi over 6 equals negative a half. So cosecant equals negative 2. We just flip it. Could we write negative 2 over 1 and still be correct? Sure. Do we have to write the 1? No. Sine of negative 300. Is negative 300 right on my unit circle? No. Is its coterminal arm on my unit circle? Yep. So if I go negative 300 and I add 360, it's going to equal 60. So sine of negative 300 actually equals sine of 60. So same thing. And what's sine of 60? Calgary Stampede. So it's your y. Root 3 over 2. Secant 60. So I need to find cos of 60 and flip it. What's cos of 60? Cos of 60 is a half. So what's secant of 60? 2. Or 2 over 1, right? Cos of 150. What's that? Go to the 150. Give me the x. What is it? Is it root 3 over 2? Is it negative root? Yeah. It's in quadrant 2, right? So our x is going to be negative. Sine of 315. So I go to 315 and you give me the x or the y. Which one? The y. So it's going to be negative root 2 over 2. Negative 30, is that on my unit circle on the 0 to 361? No, so I'm going to find its bestie coterminal angle. So I'm going to go negative 30 plus 360, which equals 330. So I'm going to find sine of 330. So what's the y at 330? Negative a half. tan of 240, so this is where it gets more complicated because you can't just take it and flip it. Tan of 240, we don't have tan on the unit circle, but we do have its best friends, sine of 240 over cos of 240. And I can just pull this right off my formula sheet, right? My formula sheet tells me this. So what's sine of 240? Y at 240. So we're going to get negative root 3 over 2 over negative a half. Now, if you see stacked fractions like that, think something is wrong. I must not do this. Okay? Stacked fractions, the reason why you must not do this is in order, that's a division sign, that black line in between, right? The only way you can divide fractions is by inverting and multiplying. How do you invert and multiply something that's in your denominator? You don't, so you sit and stare at it sadly. So remember, when you have stacked fractions, think to your head and be like, she told me not to stack them. Why? Oh, right, I need to write them out sideways. So I'm going to get negative root 3 over 2 divided by negative a half. And so I get negative root 3 over 2 times 2 over negative 1, which is actually negative 2 over root 3, 2 root 3, sorry, over negative 2. The negative 2's cancel, and it's just root 3. Is tan positive in that quadrant? Yeah. So it's good that our answer is positive. You're going to do tan of 480. Try that one out. And then this one, cos with the squared in the middle, that's just another way of writing this. Cos 225 squared. And remember, can we not check every single one of these by typing them into our calculator and seeing if they match? Yeah. So you're going to try E into F. And this example here. Oh, I don't even know what I just did. I moved stuff. And this example here. The other piece of homework is number 9. Page 202, number 9. So for tonight's homework, you have page 202, number 9, and then 12 ABC.